वेलकम बैक गाइस। हम करेंगे काइनेमैटिक्स क्वेश्चन 17 से 18 तक। क्वेश्चन 17 एंड 18। क्वेश्चन 17, a girl of mass 35 kilograms on a bicycle accelerates from rest and travels down a slope in a straight line. एक स्लोप है और गर्ल उससे बाइसाइकिल पे जा रही है. The girl does not use the pedals. Shows that figure 1.1 shows that the gradient of the slope is constant. So there will be a constant acceleration. At t time, at t1, here, her acceleration starts to decrease gradually until she is traveling at a constant speed in her straight line. ठीक है ना? Her acceleration starts to decrease. अच्छा, मैं आपको भी समझाता हूँ. I will explain in a minute. Like, पहले ये क्वेश्चन पढ़ लें. क्वेश्चन on figure 1.2, sketch a speed time graph for the girl from when she starts moving until she is traveling at a constant speed. अच्छा, फर्स्ट ऑफ ये वाला पार्ट जो होगा, दे हैव ऑलरेडी मेंशन्ड कि द गर्ल एट फर्स्ट इज ट्रैवलिंग एट अ कांस्टेंट एक्सेलरेशन. कांस्टेंट एक्सेलरेशन मींस कि उसकी स्पीड हर सेकंड के बाद सेम अमाउंट ऑफ स्पीड विल इंक्रीज. सो दिस विल बी कांस्टेंट एक्सेलरेशन वाला टाइम. उसके बाद at time t1 her acceleration starts to decrease gradually until she is traveling at a constant speed in a straight line. Her acceleration starts to gradually decrease. तो ये इसकी acceleration decrease हो रही है, right? और उसके बाद वो आ गई है एक constant speed पे, which is from here to here. ठीक है ना? This is gonna be the constant acceleration. This will be a this will be a decrease in acceleration. It is just increasing at a decreasing rate. और उसके बाद this is a speed, constant speed. मतलब the speed is no longer changing. So yeah, state state how the distance traveled is found from a speed time graph. Speed time graph से distance travel कैसे पता चलेगा हमें? It is area under the graph. So this whole region will give us the distance. ठीक है ना? It will give us the distance. Speed time graph का area under the graph gives us distance. अच्छा, कौन सा क्वेश्चन था? फॉरगॉट. क्वेश्चन 17 and 18. 17. अच्छा, this is the answer for one, or this is the answer for area under the line will give us the. Okay, this is the right answer. Moving on, question 18. Figure 8.2 is the velocity time graph for the ball. Velocity time graph है. अच्छा, मैं आपको velocity time graph explain करूंगा. एक बना लेते हैं हम लोग. We call it a diagram. So this will be a graph. पहले जो बॉल थी, it was going upwards, right? पहले it was going upwards, then it comes to a rest. एक टाइम आएगा जब आप बॉल ऊपर फेंकोगे कि वो रेस्ट आएगा and it is changing directions. पहले ऊपर जा रही थी, अब नीचे आएगी. So this will be the change in direction. अब बॉल है, नीचे गिर गई है. ठीक है ना? वापस जमीन पे आ गई है. अच्छा, फर्स्टली when the person which is throwing the ball throws the ball, it will have a maximum velocity. Maximum velocity होगी, and this will be the time where the person throws the ball. ठीक है ना? And it's अब जब ऊपर जा रही होगी बॉल, राइट, उसकी वेलोसिटी डिक्रीज करेगी बिकॉज द ग्रेविटेशनल फोर्स इज पुलिंग द बॉल. तो उसकी ग्रेविटी डिक्रीज होगी, राइट. उसकी ग्रेविटेशनल उसकी ग्रेविटी कह रहा हूँ डिक्रीज होगी, उसकी वेलोसिटी डिक्रीज होगी, एंड उसकी वेलोसिटी डिक्रीज होते होते वो this point will be this point on the ball where the velocity is zero. The ball is not moving for that split second. the ball is not moving and the velocity is zero. Then when the ball changes the direction, it starts to, अच्छा अब इसका कलर चेंज कर लेते हैं सॉरी, it starts to gain velocity, but in the other direction. It starts to gain velocity, but in the opposite direction. That's why the velocity is in the negatives. So it starts to, what do you call it? It starts to gain velocity in the opposite direction, which is this direction. ठीक है ना? और उसके बाद eventually it hits the ground and it rebounds. Sorry, let's use this. Actually, that's opaque. So let's use this. At this point, ball hit करेगी and it like खत्म हो गया graph. It's not no longer showing the further what is happening further than that. अच्छा, one figure 8.2 shows that immediately after being hit, the ball has a negative acceleration. The ball has a negative acceleration. Negative acceleration refers to this point. ठीक है ना? The velocity diagram shows for a ball, the ball negative acceleration state a name given for acceleration. Negative acceleration is deceleration. That's what negative acceleration is. State how the graph shows the ball has a negative acceleration. It's in the negative area. That's why 18. It is in the अच्छा एक second negative gradient. ये मैंने आपको बोला है. I told you. Sorry, I told you this. Line slopes downward. ठीक है ना? Negative gradient means there will be a deceleration. Using figure 8.2 at time the time at which the ball stops moving upwards. This is the time. As I told you, this is the time where the ball stops moving upwards. It is a split second where the ball is like resting. So it is this point, which is almost 9. Yeah, 8 point. It is 8.8. Let's say it is 8.8. 0.888. 0.88 seconds. Let's check that. 0.88 seconds. Okay. The distance traveled before the ball stops moving upward. अच्छा, now we'll have to find area under the graph. And हम ये वाला निकालेंगे before the, उसने बोला है, he told us before the ball stops moving upwards. So we'll find this area. So in order to find the area under the graph, we'll have to apply the triangle formula, which is 1 divided by 2 into base which is 0.88 into height, which is 9. Is it? It is 8.8. 8.8, 0.88, 0.88 into 8.8 divided by 2 will give us, actually, रुको. This is the point and this is approximately 0.9, which is actually 0.9. And this is 8 point. अच्छा, अगर हर बॉक्स आंसर क्या है? अच्छा, हमारा आंसर सही आया है एक्चुअली. 880 रख लेते हैं. हमारा आंसर सही आया है. So this will give us 3.72 something. Let's check. This will be the answer, which is 0.87872. 3.872. Acha, meters. This will be the answer. Part 3 suggests why the graph in figure 8.2 is almost vertical when time is equals to 1.84. The ball is rebounding. Ball नीचे लगी है and there is a sudden acceleration and which will cause the ball to go upwards. ठीक है ना? So there will be a rebound. Ball will hit the ground. So let's see, ball will hit the ground. Short time for deceleration or large force on ground is hard. अच्छा आगे. Figure 8.2 shows that the ball remains stationary after a time of एक second after a time of 1.84. Describe the change in energy that is occurring at 1.84. 1.84 they have asked specifically 1.84, and 1.84 पे क्या हो रही है? The ball is rebounding from the surface, and when you hit a surface very hard, you will see that there is heat and internal forces are increased, internal energy is increased. So that means internal energy of ball and ground has increased from kinetic energy. It is increased from kinetic energy. तो अब ये हम कर लेते हैं कॉपी, इसको इधर रख देते हैं, आगे देखते हैं. For this ball moving in the way shown, the effect of air resistance is negligible. Effect of air resistance in this ball is negligible. That's what they're saying. When a ball has a much smaller mass, it hits vertically upwards at the same speed. Air resistance produces a noticeable effect on the motion. When a ball of smaller mass, जब एक ball of smaller mass is thrown, there is air resistance experienced. Even if the force applied is the same, अगर force same भी हो ना, फिर भी air resistance will be experienced much more noticeably than in this ball. आगे पढ़ लेते हैं. Suggest two ways in which the velocity time graph for the ball with a smaller mass differs from figure 8.2. अच्छा जी, अगर आप फॉर एग्जाम्पल इफ यू अगर आपने एक पेपर का बॉल बनाई हो एंड यू हैव क्रम्बल्ड इट and you throw it with your like as hard as you can, it won't go as far as a tennis ball would go, right? है ना? यही बात है ना, कि अगर आप एक टेनिस बॉल को फेंकोगे फुल जोर लगा के, then it will go further than if you would throw a paper ball. So that means that it will travel a shorter distance. First of all, it will travel a shorter distance. Second of all, if it's traveling a shorter distance, then it will have a shorter time. ठीक है ना? It will have a shorter time because it is traveling a shorter distance. So that is the right answer. Let's see. Okay, that's it for this video. I hope you enjoyed. Thank you for watching. Allah Hafiz.